Sounds like you need it.
Yeah,
Sounds like you need it.
That's at like 5:30. I'll be there. Just chucking pictures.
I was gonna want to go to Browse at 5:30, but now you're gonna be there.
Yeah, because everyone just wants to go browse at 5:30. It's just a typical thing that normal people want to do.
The whole non-freshman fever.
To walk back with my girlfriend's, she looked at that one after like university on Francis, so I can see all the different mini Wanders, restaurants. It's a very interesting.
It's a very out of mix.
This one shows the position.
Yeah, we were really busy.
And then just to point that out, that it's in the audience.
What are you supposed to do?
Friday, Saturday.
Friday, Saturday, they always care. Thursday, like, that's like, once it gets full initially, then they're
And then
gonna
it goes to
like, once you have a line, then you.
spokes and stuff, I guess. To the track.
Are
Are we ready? We are on it.
Thursday.
Okay.
Yeah, it's like 7:30, it's like a freshman, it's like 16 years old.
Good morning. Welcome to Weather Watch today. Today we have a bunch of lots of different things we're going to look at. We're going to start with the tropics, and I guess a lot of the focus will be the tropics and how it's influencing mid-latitudes, as well as the looking at mid-latitude cyclones. And since in 452 we've already begun, and 751 we've begun discussing potential vorticity, we'll try to look at some different analyses of potential vorticity and kind of explore it a little bit more deeply than we did in class yesterday. So I'm starting off with the National Hurricane Center page, which shows Hurricane Sam out here in the Atlantic with 150-mile-an-hour winds, 130 knot winds, central pressure of 936 millibars. It's moving to the north at 18 knots. It was moving to the north-northwest earlier, so it's already begun its recurvature. Island of Bermuda, I think, is right there, and they're expecting maybe some tropical storm force winds in the next day or so as Sam skirts by. Sam has been a major hurricane for much of the last of this current week, and is expected to maintain that intensity for at least a few more days before it begins to weaken in the colder waters of the Atlantic, and it's expected to continue moving towards the north. So if we were to click on onto Sam, and then look at the, you can go to the graphics so it's a little bit larger, please. Sorry, can't click on that. It's already clicked on warnings and cones. Scroll down a bit. So this shows the cone of forecast uncertainty. Remember, this is not generated from dynamical forecast. This is the width of the cone is based on historical forecast errors for tropical cyclone tracks over the last few years. They update it every year based on how well they've been doing. And so it doesn't really give you dynamically the sense of how broadly spread out these, the uncertainty is in the forecast. But they expect it to be major hurricane at least through tomorrow evening, and then by early Sunday it's a continued weakening, and then a post-tropical cyclone with hurricane force winds as it gets into the North Atlantic. You can see Bermuda has tropical storm warnings currently with a blue shaded region right there, and you can see the track. The filled area shows the orangish yellow area shows the extent of the tropical storm force winds, and then really tightly clustered hurricane force winds really, really close to the center there. And that's the forecasted track of the cyclone, again, well east of the East Coast. So that's Sam today. What I wanted to do next is to show you something that's really interesting. NOAA, working with a company called Sail Drone, that's over on the, I think it's not bad. Back on, I think it's one of these, no, it's this one, let's try this one. Oh, right here, that's it. Working with a company called Sail Drone, has an unmanned, uncrewed, easily deployable device, or I shouldn't say easily deployable, but deployable device out in the North Atlantic that is kind of a drone ship or drone surfboard with what they call their hurricane sail that they put on it that's kind of rigorous. It goes out and takes measurements of the hurricane. It takes measurements of wind, has a camera on it that shows sea state, and they also get some other quantities from, I guess, ocean temperature, and I don't know if they actually have anything that extends deep into the ocean or into the ocean to make measurements. But this is, again, an unmanned, uncrewed vehicle that they've deployed into SAM for the first time that they've used this vehicle. And if we scroll down a bit to the second YouTube loop, you can see they make it, this is just showing some of the winds around in the eye, you can see of SAM. And it shows the position of this. If you play that video, you can just kind of get a sense of the sea state, but it's clearly pretty close to the eye, not quite in the eye. I guess the eye is right here, but this is where this sail drone, it's called, was located. Get a better sense of where this is. Again, this is not quite in the eye, maybe near the eye wall. Let's go to the other image so you can get a sense of the sea state from the camera that's on that. I think it's just kind of really, really neat seeing new technology being deployed to measure the atmosphere. So wouldn't you love to be on that surfboard, maybe chained to it so you don't fall off, but on that sail drone. But look at this, I mean, this is just amazing. I guess the seas were at about 50 feet or so for some of the sea state with the waves rising that high. Just really impressive, kind of disturbing kind of image. But the first time this has been deployed, this is captured from the camera just yesterday. From that. So NOAA's really doing some exciting things with technology, and that's an example of that. So, we have we have the crewed aircraft that fly into these storms. They actually have some uncrewed aircraft that NASA maintains, what's the Global Hawk that NASA maintains, that takes, does drop zones and things like that, sampling.
But they don't do the Global Hawk every storm, it's just when they have an experiment.
Right, so yeah, the Global Hawk is something that, as Greg was saying, only when they have an experiment, but NOAA has their aircraft. NCAR sometimes helps out with NOAA missions if there's a problem with the NOAA G4. Michael, that group. Yes?
Is it able to extract any information from the video?
That I don't know. I think it's mostly the instrumentation. The video's there just to give a perspective of where it is, what's the sea state look like. They may have to be able to do some measurements, but we can probably put that link on the Weather Watch page and save it so you can look back at it. There's an article there, but I don't believe they have anything quantitative to get out of the video, but I may be mistaken. There's certainly data in there that could be useful. Now this goes out, I don't know how long it stays out, but it's got a bunch of sensors. Kind of a neat idea, and neat to see it actually tried out for the first time. Okay, so the theme of today, we're going to start off with the tropics, is the influence of the tropics on mid-latitudes. And I have so many tabs up here, trying to remember where we're going to start. Let's go to the Chrome window. And this is something that caught my eye on Twitter earlier this week, which shows winds at 250 hectopascals, so that's the color fill pattern, along with some streamlines of the flow. And then the sea level pressure minima that show up on this. And unfortunately, we can't stop this. This is, but still, this is from the Tropical Tidbits page from earlier in the week. And there's a typhoon, Minjul, I believe it's pronounced, just passing to the east of Japan this morning, in fact. So near the end of this loop is sort of the current time. This goes out beyond this time period. And what we're looking at, you can see the cyclone as it approaches, is this huge amplification of the jet. Okay, the jet gets really, really strong, and then downstream of it you get what's called a wave breaking event. See the flow gets really meridional to the east of it, and you see waves that form downstream of it and continue on over us. And the idea here is that as we watch the evolution of this, at least in a forecast sense, is that these weather systems that you think about their destructiveness and their impact when they make landfall or get near landfall as it's passing by Japan, you kind of think of that, that's a local effect. Maybe if it travels like the Ida from several weeks ago, it hit the Gulf of Mexico, then it moved inland over the southeastern United States into the northeast, where there's lots of rainfall. You think kind of along the track of this is where the impacts are going to be. But the reality is that these tropical cyclones don't just have a local impact in the country that they hit or the region of the world that they hit. They can actually have a huge, expansive impact across the entire hemisphere. And that's through the propagation of Rossby waves And part of it's due to the influence of the outflow of these tropical cyclones in the upper troposphere. They elevate the troposphere, they cause the tropopause to buckle, we'll see that, creating these strong jets. And then these jets can, the energy of these jets can then be radiated and transferred downstream rapidly and have an influence on the larger scale circulation, longer than the life cycle of this tropical cyclone. It'll eventually die and decay, but it can have an impact. And one of the particular impacts it's going to have, we'll see, is on the creation of a really strong short wavelength disturbance that's going to approach the western coast of Canada later this weekend, in which the cyclone deepens from 900 on the 980s down to 950 in a matter of 24 hours. If we scroll down a bit, or maybe it's the next image on this. No, scroll down a bit, please. A little bit further, a little bit further. Next image coming up down here. This is a loop that covers roughly the same time period that shows the dynamical tropopause. And this is the potential temperature along the two potential vorticity unit surfaces. There's the tropical cyclone, and also sea level pressure isobars are shown there. You can see the warmth generated from the outflow of this tropical cyclone as it moves northward. The enhanced temperature gradient along the dynamical tropopause is in fact an upper front that is being formed. Instead of a surface front, this is an upper front that gets formed. And that upper front is going to be associated, that's very strong temperature gradient along the dynamical tropopause is associated with a jet. We saw the jets in the other image earlier. And so you can see this air coming out directly from the tropical cyclone. You can see it kind of curling back to the south. But as it amplifies to the north, the circulation around this is helping to drive northerly winds and amplify this cold trough to its east. As the cold trough itself begins to amplify, it drags even more warmer air from low latitudes northward. In fact, if you look at this map, kind of stare at it, you see these plumes that are getting generated from deep in the tropics. Some of it's outflow from tropical cyclones, some of it's just outflow from general convection at very low latitudes. This has a big influence even over parts of central North America, over us. And it might be argued, I haven't done the analysis, and I certainly look to Greg for his assessment of this as well, that the warmth that we've had, the almost 20 degrees above normal, above average temperatures we've seen for high temperatures this week, and will continue to a lesser degree next week, might very well be influenced by these typhoons out of the West Pacific, or just from convective patterns of the circulation down at very low latitudes over us. Yeah, Greg.
Also, I'd like to add to that these ridges that are being moved up, and the amplification of this wave train is also associated with the formation of atmospheric rivers. Because at low levels with these ridges, the anticyclonic circulation tends to bring moisture to the western side of these ridges where it moves up as what we look at as an atmospheric river. So atmospheric rivers don't just spontaneously rise up into the northern hemisphere, or I shouldn't say rise, but move forward in the northern hemisphere. They're driven that way because of these ridges and because of tropical plumes that are anchored in the upper atmosphere, not at the surface. So in that way, we've been looking at these atmospheric rivers as a reflection of the upper level plumes rather than what's going on at the surface.
Right, and so an example of something that was perhaps atmospheric river-like that was mentioned in one of our discussions in 452 earlier this week, maybe on Tuesday, is you can see this little ribbon of warmth that's coming up ahead of this mid-latitude, and even this mid-latitude cyclone right here with a strong southerly flow. You'll see it in the sea level pressure isobars. This is air that's moving northward, poleward. It's ascending along isotropic sheets, and then it moves moist adiabatically above that. But that ribbon of air with strong winds, strong water vapor flux, northward poleward flux, is what's called an atmospheric river and can produce significant rainfall. And so we saw places in British Columbia and Pacific Northwest where they received lots of precipitation earlier this week. So, these structures are kind of interesting, and we're going to look a little bit more at these structures. And so the way to look at this map is typically when we see these warm or high potential temperature anomalies on a map, or potential temperature distributions on a map like this, where locally it's at least anomalously warm, this is associated with an anticyclonic circulation. When we see regions where it's cold along the dynamical tropopause or lower potential temperatures, That's associated with a cyclonically curved flow. So if we go to the PDF file that we have up there, the variable that's being plotted, for those of you that might be able to see it, sorry, I should have put it in the, we'll put the number 3 first. We're looking at a variable called potential vorticity, which is a product, for those of you that have had some dynamics or some optics right now, it's a product effectively of vorticity times the stratification. And so this shows some canonical structures or the building blocks of weather systems in mid-latitudes. One is a situation, so let me orient us. This is a cross-section through what we call a tropopause undulation. It would be manifest on a weather map as an upper trough-like feature. These lines here are potential temperature. These other lines here are isotachs. The flow is in here, out here, and here in this very dark line, right here, is our dynamical tropopause, which separates the tropospheric air that has a weaker stratification from the stratospheric air where the stratification is higher. In fact, because that stratification is higher, right, the minus d theta dp, that's going to give you higher values of potential vorticity in the stratosphere than in the troposphere. The winds, again, are cyclonic, so it's in here, out of the board, so you have a nice cyclonic circulation. And the structure of these anomalies, as we talked about in 452, are that it's warm above. You can see where the isotropes dip downward and potential temperature in a stably stratified atmosphere increases upward. And beneath these anomalies, this anomalously high potential vorticity, at least in the horizontal, it's cold and more weakly stratified beneath it. And again, this is assuming no temperature perturbations at the surface. The reverse of that are those anticyclonic plumes that we saw being emitted from the tropical cyclone, in which we actually have the dynamical tropopause elevated, so that potential temperatures along this surface are actually warmer than their surroundings. And so this is going to be associated with flow in here, out here, and anticyclonic circulation. And beneath this anticyclonic potential vorticity structures, we'll find the temperatures are warmer. Above it, we'll find that they're actually colder. And so, the claim is that at least in the upper troposphere, where potential vorticity is largely, the gradients of potential vorticity are largely concentrated near the tropopause, these are the features that kind of dominate mid-latitude weather systems, at least at upper levels. If we scroll down, oh yeah, you're doing great.
I was going to mention that at the surface, with relatively cold column in the upper figure, you tend to have lower pressure at the surface. I think that's what.
Yeah, that's right. Actually, thanks. That's an excellent point. So, what Greg is saying here is that, the other thing I mentioned these isotachs, but I didn't emphasize, just beyond the fact that the flow is in the board here and out of the board here, the plane of this board. Notice the isotachs increase downward. So the winds are still cyclonic downward. And so this upper trough, this is a so-called cold core cyclone, might be like a cutoff on a weather map. This cold core cyclone can have a weak residual circulation at the surface.
And the same thing in the other one.
And this one could be a weak anticyclonic circulation at the surface.
And the anticyclonic circulation at the surface is what piles up the mass on the left-hand side of that figure to produce the atmospheric rivers.
Right, so on this, so the flow is north, this would be northward flow. If you imagine this is a cross-section through one of those atmospheric rivers.
There's a confluence on the left-hand side
Right.
at the surface where this ends and the ambient atmosphere begins. So there's a kind of a frontogenesis, if you want to call it that, but with moisture.
Mhm.
It concentrates moisture on the western side in a southerly or poleward direction.
Right, so if this is across a west-east cross-section, this will be the poleward flow on the east side of those anticyclones. And there are mechanisms we'll talk about a little bit later that can help begin developing a front right along this northward flowing air. So you pile up moisture, you have confluence there, and you can get frontal circulation that can produce precip. But before we get to that, these are the upper tropospheric structures, but we also have two lower tropospheric structures to also consider. So the next slide below this shows, let's get rid of any PV anomalies at all in the atmosphere and just make the surface itself warmer. This gives us, the solution to this is assuming gradient wind balance and hydrostatic balance. Gives us flow into the board here, out of the board here. We have a nice strong cyclonic circulation at the surface. Here are the isotachs. And so that cyclonic circulation extends upward maybe even all the way up to the tropopause. You could have a weak residual circulation there. And then the converse is true if we have it colder than normal at the surface where the isotropes go upward. And again, no PV anywhere in the interior of this, or no PV anomalies anywhere in the interior, you get an anticyclonic circulation at the surface. So this will be like a nice warm core surface-based cyclone, really cold high in the middle of winter with an anticyclonic circulation at the surface. So you have cold anomalies at the tropopause, which are associated with those cyclonic circulations, warm anomalies at the surface associated with cyclonic circulations, warm anomalies at the upper troposphere associated with anticyclonic circulations, and cold anomalies at the surface, colder regions at the surface associated with anticyclonic circulations. And frankly, these four pieces of the puzzle are the building blocks of, the large-scale weather systems you see in mid-latitudes, with the exception of isolated PV anomalies that might occur because of diabatic effects in the mid-troposphere, away from the tropopause, separate from any tropopause depression, and away from the Earth's surface. So those are all the pieces. If you understand the distribution of those pieces, you can understand the dynamics of the mid-latitude flow.
I'm going to point something else out.
Yeah.
I think it's related to this. Go back to the last picture again. When you see that tropopause in the upper figure dropping,
Yeah.
and if you think of the whole column of air going all the way up the stratosphere, what is that doing? Is that making it more dense or less dense?
Fundamentally, you're going to see pressures dropping here, but the integrated flow is going to be less dense above it.
So you should get low pressure at the surface.
Right, so you got a cyclonic circulation at the surface. Yeah, and one of the interesting things is, you look at these isotropes here, look like they're bowed up really strongly, right? You see the structure, it's cold here. But it's also, these are bowing downward, not as much, but because the stratification is so big, just a small deviation here can create lots of warmth up here. And the integrated effect of this warmth is going to be a cyclonic circulation.
That's what's puzzling, because when you integrate it, what happens up high, even though there's very low density, makes a huge difference at the surface.
Right.
What the hydrostatic pressure is going to wind up being.
Exactly.
So that bowed tropopause has a really strong effect on the surface pressure. And the upper bowed tropopause over here, remember those cold temperatures in the anticyclone where the tropopause is bowed up.
Yeah.
Those tend to be the coldest temperatures on the planet. Where that is, when those upper, those ridges where they're bowed up, they get as low as -80.
Right, which is a good reminder that when we see these dynamical tropopause maps where it's warm in terms of potential temperature, it's really cold.
Yeah.
The actual air temperature is really cold.
And that winds up making high pressure at the surface.
Right.
And that's, again, the circulations around those high pressure systems at the surface create the atmospheric rivers. Dynamic.
Right. So the final piece of this is the slide number 2, which kind of shows how you can understand mid-latitude cyclogenesis. Again, we'll talk about this a lot more in 452, but just to give you a picture, the classic picture for cyclones to develop, at least in mid-latitudes, is you have some upper trough, maybe a cutoff, or it could be in this case, an upper, tropospheric shortwave, and we'll see an example of this on the maps in just a moment. Upper tropospheric shortwave that approaches a region that has low level baroclinicity. So these are isotropes, colder to the north, warmer to the south. As we just said, there's a nice cyclonic circulation that's strongest at the level of this anomaly. It effectively penetrates downward. It can reach the surface. That circulation you see at the surface is associated with this upper anomaly. What's happening here is we have southerly winds. That's advecting warmer air northward. And so over time, we create a thermal ridge because we've advected warm air northward. And we've just, going through this discussion, warm surface temperature perturbations are associated with a cyclonic circulation at the surface. That cyclonic circulation at the surface can extend upward and interact with the upper wave. And what it's going to do is try to advect higher values of PV from the north down into the wave and amplify the wave even more. And you get this mutually reinforcing pattern that leads to the development of a cyclone. The strongest cyclonic circulation isn't going to be directly beneath the upper wave, that's what the black arrow shows, nor is it going to be around the warm anomaly at the surface, which is what this white arrow is showing. It's going to be somewhere in between these two, and we'll see this again when we look at surface maps with isotherms on them. You don't see the cyclone at the, the top of this, or the northern part of this thermal ridge, nor do you see it in the thermal trough. You see it somewhere almost halfway in between. And then along it, you have your warm fronts and cold fronts that are developing associated with the system. But one of the curious things, and you have to scratch your head a little bit, when you talk about cyclogenesis, often, people might use terms like removing mass out of the column. And that's going to be necessary fundamentally if you're looking at how much mass is in the column. You talk about divergent circulations, well, that's how you're going to move that mass out. I've described this process without even referring to any divergent flow whatsoever, without referring to how the mass is changing explicitly. It's just advecting potential temperature at the surface and PV aloft. That's it. And it's kind of a nice, conceptually it's nice. It hides a lot of the messiness under the rug, if you will. You see in my office, I have a lot of stuff in my office that's so messy. But the complicated part of it, if you're interested in diagnosing vertical motion, you can still do it within this framework and get the age-restricted winds. You can still do it within this framework. It gets complicated. There are other tools you can use to do that. We'll be talking about that, obviously, in 452 very shortly. Anyway, before I get off of this, any questions? Okay. So, what I would like to do next on this is, before we get to go back to the current weather, I think I have those up as tabs on the old, we don't need to go to this. Actually, yeah, you can just do that. Click on this for a second. This one. And we'll go to this first one. I want to just look quickly out at the monthly outlook for us. Kind of doing the forecast backwards. Above normal temperatures expected over, this was issued just yesterday, so it's hot off the presses, and we stay hot. At least this is what the CPC forecast is. Above normal temperatures for the upper Midwest. Over Alaska getting cold, and Pacific Northwest a little bit below normal. Kind of unclear what's going to happen out here, but it's like a strong signal for a warm October coming up. If you go to the next slide, next link, this is one change that's kind of nice. Above normal precipitation in the northern, central, and southern plains, as well as part of the Midwest. So we might actually get some much needed precipitation above what we would normally expect to get during this time of the year. Staying dry over the Northeast, but also where it's been dry for a long period of time over the Pacific Northwest. Also, looks like it's going to begin opening up. And I think this is the season where they begin to get some rainfall, so it's above what they normally would be getting. Very last thing, I don't remember where this is. Actually, go to that other window for one last quick look. No, sorry, the Chrome. Get that one. This is a animation. I hope it starts to play. Click on it. This is an animation from East UW-AOS. It's out to 360 hours for the first 15 days of the month. That's been posted by someone on Twitter, Eric Fisher. And this just shows, you can see night and day going by here, but the temperature anomalies at the surface for the upcoming month. And it's just, if you like fall and you like cooler weather, I mean, obviously we're cooling off, but we're still well above normal. This is just going to be a warm period, if this verifies. Again, this is the first 15 days of the month from the ECWF forecast. The anomalies get a little bit smaller over time, but they're still above normal. Normal for us, average temperatures are around about 65 or so this time of the year. Okay, thanks, Pete. We can shut these.
I have a question.
Yeah.
Are you, in the order you've done this, are you suggesting that this warm-up may be tied with tropical cyclone activity in the Pacific?
I think with what's happened recently, it seems like I think there's probably a link to this. I would believe that there is a link, yes. Kind of disentangling that and understanding what's the cause and effect. Certainly going to take a lot of time, but it's worthy perhaps of a case study once the season's over, if this actually verifies, to see what those relationships are. But yeah, that's the motivation for putting these in this order. I was just thinking about the warmth we've had. We've seen these ridges, these plumes coming off the Pacific. What's the relationship between the flow out over the Pacific, particularly the Western Pacific that's been active in terms of tropical cyclones, and our weather here. Okay, so we can close that. We can close that up too. We're done with that. Please, Pete. I did mention normal temperatures. You can click on that. The climatologist data. Again, our normal or average high temperature this time of the year is about 65, 66. So we're in the mid-60s for the next, week or so. And then we begin our drop into, our descent into winter. But, again, yesterday we were about 20 degrees above normal in the mid-80s. Today we'll probably get pretty warm. So, okay, so let's move on to the next precip. We've reached the end of our Happy New Year. The Happy New Precip year. We're going to start this map again after today. But this shows the deficit we had over the current year, or the end of our current water year, several inches down. Okay, so here's the current satellite image. You can see SAM out here in the North Atlantic. We've already talked about SAM. And you can see an area of sort of cyclonic turning out over the four corners reaching the United States. And we'll see that's associated with a sort of mid-tropospheric potential vorticity structure. And then a lot of clouds out to our west and our south. We'll look at some of the dew points and temperatures. But there have been some convection, some thunderstorms that developed over Texas yesterday evening. I guess they've now moved eastward toward the Gulf Coast. We'll see that on the radar in just a moment. But a pretty quiet period over us right now. You can also kind of get a sense of where the low dew point area is, even with the sun shining. Not a lot of cumuliform clouds forming over the mid-Atlantic through the Midwest, but you can see south of this band of cloudiness, a lot of cumulus forming over the southeastern United States, Florida, North Carolina. Kind of a boundary that exists there. Let's go to the next map. Here's our radar summary for the U.S. There's that convection over eastern Texas. Some small thunderstorms, some isolated thunderstorms, not really well organized over Arkansas and Missouri. And then in the Dakotas, some looks like more stratiform type of precipitation. We'll see if we can diagnose some of the structures that are causing that in our discussion. Next map, please, the U.S. map. So last hour, 73 over 58. Here at Madison, you can see the dew points largely in the 40s, upper 40s into the 50s. And then when you get further to the south, there's dew points begin to jump from the 40s and 50s to the 60s. And that was kind of, saw some evidence of that in the types of clouds that we're seeing, or the lack of clouds to the north of that. Where dew points in the mid-60s or upper 60s in the southeastern United States, down into Florida in the 70s. Some heavy rain. That's not good, Tampa. 88 over 73 there. And then in Florida, looks like more rain as opposed to showers or thunderstorms, but these are 74. Temperatures, I think this is Houston's here. This is College Station or Waco, 74 over 71, with some moderate rain at that station.
I have a question. Are the fires on the West Coast mostly out now?
I haven't heard much in the news about them, but maybe because they're focused on other things. The question was about fires in the western United States. Has anyone heard anything recently about the status of those? I don't know, is there a fire page on Sims, the Sims or SSC?
I got some pages that Maggie shared with me on the Weather Watch page.
Okay.
So if you wanted to know about actively burning fires, you can use fire weather avalanche.
I don't know if I have that one on here or not, Maggie.
You can look at, go 7.
Yeah, there-
Yeah, that one.
Are they out? It looks like, no.
There's a lot of fires, but I don't know if there was a lot of smoke.
Right. You take a look at the West Coast satellite image. You can
So
see-
if you click the, we have a listing on, what each one is. I'm trying a little.
Oh, so you click on each of these little flames, you can get some idea.
You
what
can get
the-
some more information
Sure.
there, but, if you want some info about like how actively burning they are, here's the legend. So these are active, but not like super active. That one's definitely pretty new, but it says it's controlled, so. Let's say we click on this one that has some, so it looks like there's
5%.
probably still some activity, but maybe not intense like we saw last year.
Thanks, Maggie. And maybe we should go to the West Coast goes, take a quick look at the, what's happening there. Also, was you able to get that large loop?
I did not do that on the West Coast yet. No.
You look at visible, or whatever the best bandwidth of smoke.
In Southern California.
Yeah, you can find smoke down here.
So it's dark.
As you can see, some of that smoke going up the valley. In this location, it looks like a lot of fires, or not a lot of smoke plumes evident. This area looks,
I think this is the best it's been in a couple months.
so the health impacts of this, people can breathe, no pun intended, breathe a little bit easier with less smoke in the air on these locations. Okay. And while we're at on the west coast, if we have a more greater Pacific view, I want to point out that developing cyclone. So we saw the big ramp up of a wave out over the Pacific in the images we looked at earlier. And here, this cloud head that's forming, approaching British Columbia coast, this is the developing cyclone that's going to, intensify quite rapidly over the next 24 hours or so as it moves south of the Gulf of Alaska toward the Canadian west coast of Canada. So this is, cloud head doesn't look particularly impressive now, but it's going to look like a nice comma head by the end of, by tomorrow morning. We'll see this when we get to the forecast. We'll finish with the surface maps. Let's go to models. I think this is pivotal. We're going to go back out of this to a view of the Pacific, so go please to global, GFS, and then we're going to go for regions. There's no great Pacific, east, well, that's too far south. Let's look at North Pacific. And we'll go to the current time, we'll go to the 0 hour forecast. And the feature to look at is this little closed isobar here, which is about 980 hectopascal. What's plotted here are, the fill pattern is the geopotential height, the 500 millibars, not thickness, but geopotential height, and then sea level pressure. So it's already a decent cyclone, a few closed isobars there embedded in a much larger scale cyclonic circulation. You also notice that this upper trough that's hanging out to the west of it, we'll see that's associated with a PD structure that we'll look at in a moment. But let's step ahead 6 hours into this. And it deepens from about 980 down to 970. As that upper trough begins to get closer and then begins to interact. Let's go ahead another 12 hours down to 957. That's a pretty decent cyclone, rivaling anything else in the Pacific Basin, at least in the North Pacific, with that, mid-deal being at 965, this is already down at 957. More intense, at least sea level pressure-wise, than the cyclone up there, and then 959 as it begins to fill. So, really rapid cyclogenesis event, and I don't think we can do a cross-section through this, but let's look at, if we scroll down, they refer to as upper dynamics, let's look at the potential vorticity of 330 Kelvin. And let's go back a few clicks to the initial time. So here's this upper trough. Here is some already existing, pre-existing vorticity of 850 hectopascal, and that's the cyclonic vorticity that's plotted here. Now let's watch as this upper trough begins to interact with this. You'll see how so it's down to 970. And as that cyclone begins to increase its intensity at low levels, it begins to drag, its circulation at upper levels begins to drag this PV around it. So you can see, kind of hard to see in this image, but this low PV that's getting wrapped to the north, getting a nice comma head in the PV structure. There it's even more evident here. Also happening during this same time period is significant precipitation that's occurring in that cloud head and in the area just downstream of the trough. That diabatic heating in the middle and lower middle troposphere is helping to erode the PV aloft, and so it decreases. The PV is not conserved when you have diabatic heating going on. If you're above that region of diabatic heating, you're going to see a decrease in the potential vorticity. That's precisely what's happening with this event. So it helps to amplify the event, and again, we'll learn about why that's the case in a little bit. So if we really intense cyclone in the North Pacific, trailing front associated with it. Another vorticity anomaly out there. And you can see the low PD from types of Minjul covering much of the western Pacific, the islands of Japan and Sakhalin Island up in, toward Russia. Okay, let's come back to the United States. We'll go to the FM5 maps. And we'll start off with everyone's favorite map, or image, the meteorogram. And we see the warmth continues at least for one more day. Maybe tomorrow being even warmer than today will be. We'll check out what the current temperatures we saw was already in the mid-70s, so tomorrow will be even warmer. And then by the time we get to Sunday, it looks like we begin to cool off a little bit. And at least within this particular forecast, and the dew point's going to climb from the upper 50s from 58 into the low to mid 60s in terms of dew points. It's going to get much more moist. And we're also going to see the possibility of up to half an inch, a little over half an inch of precipitation starting really sometime early Sunday morning. Little bits and dribbles of precip tomorrow evening, but the biggest threat of precipitation, at least according to this model forecast, is going to be on Sunday morning and
Sunday or Saturday. Saturday is the second, right?
I get my days wrong.
Oh, see, Saturday would be Saturday morning.
Something's wrong. Is this the old, all right, let's go back to like thanks. That's why it didn't make any sense. Can we refresh that?
So let's see today. Should be. Looks like it's from 0 Z last night.
Yes, those are from 0 Z last night. My apologies. So here's our warm day today. Tomorrow's gonna be cooler. Gosh, that's why this, I looked at this earlier and it doesn't look like the other forecast. The timing looked a little weird. So this is actually rainfall tomorrow morning. But maybe up to half an inch will be convective precipitation. Let's go back a click and look at the time height section. Again, this is from last night's forecast. Thanks for pointing out. So isotropes are shown here. Relative humidity is in yellow, relative humidity is in red, and this is vertical motion. You get this nice big pulse of upward vertical motion, ascent tomorrow evening, as these are probably thunderstorms begin to go by. And then the wind shift more to the northwest when we begin to dry out. This looks like it's more convectively forced, but we can take a look at a couple other diagrams to get a better sense of this. Let's first look at the surface map. And what you'll see is very unorganized here. Precip, let's start at 6 hours in the forecast. Oh, we can go further ahead to 18 hours. This is right about now. So you saw in the maps that we were looking at earlier, there was a little bit of precipitation down in the in Arkansas and Missouri, as well as in eastern. This is accumulated precip, but there was precipitation also in eastern Texas. I don't believe these were actually well represented in our radar summary that we looked at. But the model from last night, at least, was forecasting some, pretty intense band of precipitation over Minnesota. Now, if we go back to our radar summary, let's just take a quick look. I think it's the second or third image there. Okay, so there is some convection there. I mean, it's obviously, this is a pretty coarse model, but there is the precipitation that was forecast by the model this morning, last night for this period. So not great, but it's there. Let's go back to the NF5. And I just realized I totally skipped the upper stratospheric maps, but we'll just keep going for today. Next, go 6 hours ahead from this, or 12 hours ahead, please. Let me go in 6 hour chunks. So this is approaching 1 o'clock tonight, 1 o'clock tomorrow morning, rather. Precipitation entering the western part of our state. But again, light winds, you can see the surface pressure gradient is relatively weak. This is going to be a pretty uninteresting period. And we go ahead another 12 hours tomorrow morning. And this is the time when we get that precipitation, the burst of precipitation by tomorrow morning as a cyclone, looks like a modest cyclone, a weak cyclone to our north Lake Superior, moves westward, or moves toward the east. And you can see the winds are expected to shift. The geosurface winds becoming more northerly once this cyclone, this area of precipitation goes by. Another, let's go to tomorrow evening. That's 42 hours. Let's go to 48 hours. And then the cyclone cyclone is just slowly, almost stuck. This is correct. Yeah, 0Z. Maybe some lingering light precipitation, but most of it's east of us along the front. So let's take a look at a different model. I just want to get a better sense because this is an older forecast. So look at pivotal, pivotal. Actually, hold these other ones. They got rid of the pads and all that. Yeah, that's good. And this is current, right? Yep. Yeah. Oh, good. So again, all these models still have the precipitation over parts of Minnesota, but let's go ahead to 18 hours of the forecast at 1 a.m. 2013 cyclones, and precipitation just to our west, so it's not too different than what we saw in the MM5. Tomorrow morning, 24 hours forecast. Cyclone is a little bit further to the west, but most of the precipitation gets by us. The trough axis is still well west of us, so maybe unsettled conditions tomorrow morning. Go to 36 hours by tomorrow evening. Still haven't had that trough pass by us, so the threat for showers lingers with the cyclone is kind of stuck in northern Wisconsin. And by Sunday morning, it just slowly creeps by. And winds turn to the northwest, so probably drier air with little dew points at this time. They were falling in at 5, and you can see lower dew points and winds. Okay, so you can see with this broad cyclonic circulation, northwesterly winds, lower dew points toward northwest. So there's only, we have mixing ratios here, we see lower mixing ratios being imported into our area, so we need to dry out. So nicer day on Sunday, then perhaps tomorrow's going to be a little bit cooler as well. If we look at temperatures and winds, you can see some weak cold advection over us during the day on Sunday. And finally going down to the surface map again. That's where we are. And we'll just step ahead for the next couple of days, 24-hour chunks. We're at 72 hours to Monday morning. That cyclone is well east of us. Broad area of anticyclonic circulation. High begins to build in. That should be a nice day. And probably the coolest of the days at the beginning of the week with 564, less than 564 thicknesses over us. Tuesday morning. High still over us and pretty dry and relatively quiet. In fact, the balance of the week is going to be just sort of moderate temperatures and very little precipitation. We can go to 120 and look ahead a little more, 144. The other area that's going to be interesting to watch is off the southeast coast of the United States. There's a disturbance that's south by the Bahamas that kind of drifts northward, and some models have intensified it to maybe a subtropical or tropical cyclone off the southeast coast. But again, for us, maybe a little light precipitation as the winds become more southerly over us, or southeasterly, east-southeasterly, and dew points begin to come back up. But still relatively dry week. 168 hours for weather watch next week. Dew points are starting to climb back up. We can look at that in a second. And then increasing pressure gradient along the east coast, probably rough seas and beach erosion, but no well-identified closed circulation yet at this point in the forecast. So let's look at dew points at this point and winds again. Again, you can see that surge of moisture air beginning to come back into our area by the end of the week. Other thing I totally neglected was talk about what's happening in our forecast city. So let's go from continental United States. Please click on local for a second. I want to see if they've focused it on. Yeah, we can try that. Washington State. And let's go to the surface map. And go to Monday, so 72 hours. Actually, not Monday, sorry. Let's go to 60. 90 hours. Yeah, so the beginning of our forecast period next week. Remember, we're forecasting for Quilly, which is right about here. So of course, it rained this week a lot. We're probably looking at more rain. Let's go ahead 24 hours from that. And actually scroll down a bit. go to 24-hour accumulated precipitation. They said total. I thought they had a 24-hour accumulated precipitation. Okay, don't have it. This is the total accumulated precipitation, but we'd have to go subtract stuff out, so this isn't any as helpful as I thought. Go back to 90 hours per second.
If you go to a regional view and have it when you simulate it.
Oh, okay. So let's get out
The
of
24 hours.
regional. Click on that. Okay. Yep, thank you. So 0.01, then we go to 114 hours in the forecast. Yeah, a wet start to next week. Again, I wouldn't trust the forecast this far out, but potential for more precipitation during the next week of our forecasting. And finally, we can check to see how we're doing. Let's go to WX Challenge. I don't have it up here yet, so you have to type this in.
Is that stationed in the rainforest?
No, it's kind of a coastal plain before we get to the rainforest, I think.
Okay, it's near.
It's near it, yeah. I think Professor Maroon was mentioning it, rainforest. Go to Challenge, they really changed this last year. Get here with results. And we can do team standings, see how Wisconsin's doing. Go team. No, we can, I think the team standings would show, should show all the different schools, right? Display. Okay.
That's the best Madison Star in Ohio.
Yep, so it's only 4 days of a contest.
Still.
Well, we're at 7th, but it looks like we're in the mix of things. Penn State and Alabama, those folks. We'll crush them, don't worry. But not bad. How many schools are in this? That's probably also helpful. So at least 32 there. We're really have enough forecasters there to be considered competitors. So something to look at. And then we can check out how we're doing here. So we'll go to start typing Wisconsin, just WI, bring it up.
I think we have a chance of something to go back next basketball message.
So Professor Maroon doing quite well up here, well below consensus. And the whole idea is to get below consensus here, get a negative number there. I'm trying to get there. And Craig Oswald, one of our graduates, alumnus, is forecasting. He's doing quite well. Jake 17. Here? So, doing well as well. This guy Morgan is kind of, whatever. But it's early days, just wait. Folks will be crushed as we go further into the forecast. And get numbers like this, see someone, talk to someone, ask questions, we'll help you out. But anyway, it looks pretty good. A good start for our team for the first week, we can move that up. And if people are interested, send an email. We could have another meeting on Monday after colloquium to talk about the forecast challenges for the week ahead. Give tips on what to look at the forecast. Check the Slack channel as well that we have. So if you really want to know, get some tips on improving your forecast, and we can help you with that. Anyway, so weekend looks a few showers perhaps. So if we could do one last thing, go to Moss, look at New Haven Moss for today, for Wisconsin, for Madison. MSS. And probably the precipitation are highest around 12 tomorrow, kind of what we expected. You see the forecast for the dew points getting up to the mid-60s, low to mid-60s, and then kind of slowly dropping off over the weekend. And not zero chances of precipitation, around 20% throughout much of the weekend, so not particularly great. And a little bit cooler by the time we get to Monday. Anyway, thank you very much for your attention, and have a good weekend. Thanks, Pete.